Query support. When we think about indexes, usually we think about using them for a basic selection query, a query of the form key operator constant, something like, age less than 20. So what we want to look at first here is what operators does the index support? A typical one is an equality operator for equality selections, like age equals 42. But we might be interested also in range selections, like age less than 20, or age greater than or equal to 5, or even age between 5 and 20. B+ trees, as you may realize by now, support both equality and range selections on a single dimension. Linear hash indexes, which we didn't learn in this class, but which are another commonly used type of database index, only provide equality, so they don't allow range selections. They're very interesting data structures, and I encourage you to go learn about them. There are other kinds of indexes that are commonly found in database systems that support more exotic selections than single-dimension equality and range queries. For example, there are indexes for geodata that support things like two-dimensional boxes. So you can imagine in a Google Maps type scenario, find all the points within the current boundaries of the map. Or 2D circle queries, like find all things within 2 miles of the Empire State Building. And so there's a common set of n-dimensional indexes. These are indexes that support queries across 2 or more dimensions, whether they're box queries or circular queries. And examples of these kinds of indexes are R trees and KD trees. And what I'll tell you about these very briefly today is that they're very useful in low dimensions, like 2 or maybe 3 dimensions, and they get to be hard to perform well when you get to lots of dimensions. And this is based on a statistical fact known as the curse of dimensionality, which we won't get into in this lecture, but you should be aware that as you go up in the number of dimensions, it becomes very hard to separate out points by distance. And so queries on these points, whether they're indexed or not, tend to be very hard to specify. Another class of queries that's interesting in more than one dimension are near neighbor queries. So for example, what are the 10 restaurants closest to the Empire State Building? The 10 nearest neighbor restaurants, if you will, to the Empire State Building. That's not a query that's exactly a box shape. It's not a query that's a radius shape either, a circle shape. It's a query that's entirely data dependent based on where the data lies. In a dense neighborhood like the Empire State Building, finding 10 nearby restaurants is probably a very small query. If you try to do the same thing in the center of America, you'd probably have to draw a pretty big circle to find 10 things close by. So near neighbor queries are very data dependent. They're not a particular shape at all. Getting on to more complicated data types and queries, you can imagine for string data, you might want to be able to support regular expression queries. Find me all states that start with a W and contain an I somewhere inside. But you obviously would want to do that on more complicated data. Other examples of string data are genomics data, which is obviously a string of base pairs, and finding matches in genomics databases is often done using index structures of one sort or another. Postgres has an interesting index called the GIST, or the Generalized Search Tree, which is a flexible kind of index that can support many different kinds of data types and queries. It was developed right here at UC Berkeley in my research group, and it ships as part of every Postgres distribution, so I encourage you to have a look at it. For the remainder of our discussion today, we are going to focus on traditional one-dimensional range search, with equality as a special case of range search, and equality is a very narrow range. It's an infinitely small range. So we're going to look at equality queries, and we're going to look at one-dimensional range queries, just the sorts of queries we look at in B+ trees.